Well, good morning, everybody. I'm going to talk a little bit about biogas-oriented circular economy and about how to ensure efficient operation in AD systems, anaerobic digestion systems. So, just short, I am representing Biogest. We are international biogas and biomethane turnkey technology provider. We have completed successfully more than 180 projects all over the world in more than 20 countries. We come originally from the wastewater treatment sector, have more than 30 years experience, and since about 15 years we concentrate solely on biogas and biomethane systems. We do also have offices all over Europe and in the US, and we also have 8 plants that we own and operate ourselves. So what we can do for you in Australia, Tasmania especially now, and New Zealand and the whole Oceania region, is that we can come and help you, the people and the stakeholders from the relevant sectors, from organic waste sectors, to develop a project. The first input, output analysis and mass energy balance. So what can you get out of your waste? How much will it bring you? And give you a calculation of that. We can then design and engineer the plant, the system for you. We also can come in with equity if it's necessary. And then we would work together with a local EPC contractor or construction company. And in combination, construct turnkey reactor design, and then bring in our own turnkey technology that is produced in Europe out of our own hand in Austria and Czech Republic. And then we can monitor your plant and understand the biology, what's happening in the digester, and do the technical and biological service. And we will train you so that you're good to go to run the plant yourself, but we can also operate and maintain your plant in the future for up to 2 years. So this is just what we do are completely steered tank reactors. These are 4 of our digester types. So we start from very small ones, the power compact from 80 kilowatt on, up to 4 megawatt. We have one plant in France with a 3.6 megawatt plant, which is the power ring with the concrete roof and 2 sedimentation traps. So we basically have technology for all kinds of feedstocks, all sorts of organic waste. We're able to digest and pre-treat and turn it into organic fertilizer and give you energy, except for wood. We have memberships all over the world, and also in the Bioenergy Association New Zealand and Bioenergy Australia. And it is important for us to put a foot on the ground in your region as well, and to bring circular economy forward, and want to show you what advantages biogas has. So it has a lot of advantages for farmers, because you can, if it's planned wisely and all synergies happen to work together, you can co-generate electricity, power and heat from your agricultural waste or organic industrial waste. And then you can turn this biogas, we can upgrade it, and we can inject it in the natural gas grid. We can electrify it and turn it into electricity and heat that can be recirculated, recuperated into your own industry. And then we can also produce organic fertilizer. So the digester that comes from agricultural plants will become very high quality organic fertilizer, and when it comes from industrial waste, we can do further processing and turn it into other valuable products. And it is important to say that farmers can, in the long run, really save a lot of money and do a lot of good things for the environment and reduce emissions. By capturing the methane from the animal waste or the organic waste, they can reduce their cost, the operational costs of their business, because of the gate fees that they have to pay when they have to bring it to landfill. So they can clean the environment, and they can create a lot of valuable byproducts out of it, such as the fertilizer, and also save money on mineral fertilizer. And they can also create energy from biomethane biogas 365 days a year, regardless of the weather. This is a big advantage compared to sun and wind. And so from today, we'll talk a little bit about the requirements for efficient operation of this AD system. So we have the legislative frame, incentives, feed-in tariffs for electricity, carbon reduction schemes, then we have the feedstock availability and quality of and the feedstock logistics, which is important to keep in mind. Also, what turnkey technology is necessary to have a good, efficient biogas plant running, and how you can lower your energy consumption within each single unit operation, and how to keep a simple service and maintenance up and alive. So for the whole biogas and circular economy, there are a few pillars that are important. So it's basically environmental parameters, technical, economical, social and legal parameters that all work together and are interlocked with each other. So environmental parameters, we can reduce greenhouse gas emissions, improve the air and protection of soil and water bodies. Then economical parameters is the whole payback time, the investment cost, and when you get that back, the amortization time with your biogas productivity. Then the whole technical approach and obstacles within the system design, and in terms of what feedstock you're using, what kind of technology we have to apply for that. And from the social parameters, all the benefits for households, farmers and industries to basically create a green energy source for themselves and their surroundings, and to produce safe food and increase the health. So this whole idea about the efficiency is basically to keep the equilibrium in control. So for stable loop systems, they need quality and quantity control, like an efficiency and effectivity control of the circulating mass flows, in order to match supply and demand and to keep the prices, costs and risks under control. And from the legislative side, there are emission legislatives that are different in each country. They might be different in Austria than to Europe. From the agricultural and fertilizer legislation, when you're able to use digestate and the application on land and the nitrogen loads. Then you have the building and construction legislations for permissions, PPAs, how to get that to bring a biogas system up to run, and also the taxes and financial legislations as safety for workers and the environment. And as a big driver why biogas and biomethane really took off in Europe is because we do have, and this is a big advantage, is from we have feed-in tariffs in Europe, incentives and incomes, and this is a big security for all investors and for farmers. So for example, in France, you get about 25 cents per kilowatt hour produced and you get for the biomethane sales in France about 90 euro per megawatt hour. And the same happens also with carbon reduction schemes, and we are committed from our state law to use biogas now as a prime energy source and to produce our own green energy and green gas. And we have up to 30% government subsidies, and in Germany even up to 50%. So almost every second farm in Germany, agricultural farm, is partly financed by the government. This is a big driver, and we're still in its kindershoes in Australia, but we have some legislative frame that we can use, and it is possible. And just from the fertilizer market, it would be interesting to say that we have also, we can get a lot of revenues just from selling the fertilizer, organic fertilizer, where we have about every second farm in Europe, in Austria and Germany is an organic farm. We are only allowed to use organic fertilizer, and you can pay you can pay 300 to 600 euro for organic fertilizer per ton. Just compared to Australia, it's about $1,300 for a ton of synthetic fertilizer. So we're really interested to help the relevant sectors and stakeholders from all sorts of industries like farmers, livestock units, piggeries, poultry and other livestock, the milk processing with the dove sludge, the red meat processing industries, for paunch, rumen, blood, intestines, offal, the food and beverage industry like breweries, distilleries, bakeries, also wastewater treatment with the sludge, sewage sludge, and of course the agricultural sector with straw and agricultural residues and leftovers. And whenever we plan a biogas plant, we always first look at the available substrate and the logistics of what we have in a certain frame from distance, and then we will decide and design the plant and the size and the technology. And we never do it the other way around. And for feedstock quality and biogas potential, that's obviously important to keep a good efficiency in your reactor. So there are a lot of numbers that we are using already from systems that we have done all over the world with biomethane potential of certain feedstocks. So this will be each time for every single unit that is planned, calculated and determined another time freshly, because pig slurry might be different in Europe, in France than in Australia. So this all needs to be kept in mind. And also from the logistics, we should always think that we should never transport any feedstock organic waste further than 20 kilometers to a biogas plant. Otherwise, we just waste it in fuel and it becomes economical and environmental unreliable. This slide is interesting. It gives you a little bit of a comparison and to tell you that it's important to understand that the selection of your feedstock and your process optimum, in what kind of relation it stays. For example, straw, the primary energy input and output of straw, to utilize straw in a digester, is very good. And if you have, for example, grease separator sludge that you want to put in, you have more energy input in handling and processing the waste, and also in the transport and the collection. So there is no perfect recipe. It all depends for each case, and based on that, we will find the perfect solution. And for the agriculture, the industry, we have different categories that can be defined. So we have, for the wastewater treatment plants, the digestion towers. Then we have high performance systems for industrial wastewater. We have biogas plants used in agriculture for manure and energy crops. Then we have two-stage fermentation systems for liquid and solid organic waste. So there are actually no boundaries, and we are equipped with the technology for all sorts of pre-treatments and handling. And also for the pre-treatment, we can say that depending on what feedstock you have, you might have a more simple pre-treatment or no pre-treatment necessary, or maybe for food waste it's more aggressive somehow. Then you have like straw, which is like higher lignocellulosic material. We have technology to cut it with hammer mills. We have technology to crush it up and break up the lignocellulosic structure to make it then more degradable for the bacteria inside the digester, which is very important when you have it in combination in the co-fermentation with other feedstocks like slurries that degrade much faster than straw. So to have an overall equilibrium. Of course, the investment costs are economical key parameters that can't be left outside. In Europe, we can say that we have approximately 3,000 to 6,000 euro per kilowatt installed. That's an specific investment cost. If you have 1 megawatt plants, they can drop down to 1,000 euro per kilowatt. If you have very small plants, they might get much higher than 8,000 per. But the thing is, the investment cost and your payback period time always depends on the good planning, and if you make use of all possible created byproducts, not only the gas, but also the heat and the fertilizer. Yeah, and so we can basically say that the optimization of a biogas productivity and of the whole system planning depends not only on the substrate composition, but also need good operation. And the whole energy and money can be saved through every and efficient single unit operation. So every wheel plays a role. If we can perform and optimize each single step, then we can create a really good, reliable, sustainable system. Yeah, for example, how you can lower the energy consumption with the heating. Like the digesters that we have, as I mentioned, with the concrete roof, gives us a very good insulation in the ring-in-ring system. So this is a big advantage compared to conventional digesters, where you have only one ring and lose heat from the outside walls, but also over the roof with the double membrane storage. So these are all things that can be compared when you say you want to maybe up to 4% from your total electric load will be going into the digester heating. But our digesters are all performing well in cold climates and hot climates. And what is very important that you keep it simple from the service and maintenance side. So any spare parts, digester, agitators that are inside the digester can be removed from outside. So you're not obliged to open the digester. You can do everything from outside, and that's a huge advantage that you can run a plant really throughout the year. Otherwise, you'll have to change a part, and then you'll have maybe sometimes 3 months where you have to wait to start up the whole biology again. And this is time loss and also money loss at the end when your maintenance is not running efficiently. Yeah, then also the technical key parameters are not only that you have 100% performance with 8,300 hours total full load. We have a very high degradation of the organic matter, and we monitor and keep all the chemical and microbiological parameters in mind, so the pH, alkalinity. We have sensoring for that, so that we understand the bacteria and always know what they're doing and what's happening inside the digester before anything could happen and collapse, especially when you have adaptations to different feedstocks throughout the year. So this always needs to be adjusted then with the biology. Yeah, and this was just like an overall introduction into this, and very happy and thank you for your attention. And I'm happy if I can help you in Georgetown, and if please find the materials and the flyers that we have, and please contact me if you're interested in thinking through a system and in planning a system for your own industry or farm unit. Thank you very much.
How do you deal with contaminants, things like heavy metals and things that would otherwise end up in the resulting fertilizer product?
So we can say that 90% of our clients are farmers, and they have a pretty clean feedstock, yeah? So agricultural waste and livestock units, breweries, all these industries, they have a very low concentration of these things. So then the digester can really be applied on land. In Europe, there are two categories for this waste that we have in Austria and Germany, and when we are able to apply it on land for safe food production. When it comes to industrial waste, water sludge, and we have higher contaminants of heavy metals and other impurities, anorganic impurities, then we can further use other technology like pyrolysis, for example, produce biochar, or turn it into fuel material, or turn it into a building material as well. So there are many options.
You can also limit the application rate. So if there are contaminants in it, you can look at the loading of contaminants, and you can apply it at a lower rate, which makes it less valuable as a fertiliser, but it's still... So Taswater do that with their sewage sludge, for instance, which is called a contaminant limit application ratio or something like that.
Yeah, we do have limitations of certain parameters, certain impurities, and as long as they are within the frame, then we have basically we have no problem to apply it on land. We have for nitrogen application our limitations, and it always depends also if you want to apply the digestate near a water body, an open water body, or to also consider the underground water, if it's, for example, at the poultry farm, and you wouldn't do anything and you just dump it there on the side, and it goes into the next where you pump out the water into a drill, and then and that goes for your drinking water for your animals. So if these are it depends on every case. Yeah, it depends on every case. But we have national laws and limitations, and as long as we're in the line with this, it always depends on what we're putting in and what's coming out. When we have, for example, dealing with very liquid, larger liquid waste streams, and we have a certain concentration of heavy metals there, we could, like we did also in Asia, in China, where I worked before for the University of Technology in Beijing, we did tertiary treatments after biogas plants, where we would treat all the, so we would have liquid and solid separation, then you would have a higher fraction of nitrogen in the liquid part, and a higher fraction of carbon and potassium in the solid part. And the liquid part, if there are still contaminations and heavy metals, we would also use aquatic plants. So there's different plants that you could use for uptaking heavy metals and harvesting schemes. So it really, really depends on the case. But the treatment is possible for all sorts of contaminations.